I've got a couple of functions here, and we're first of all asked to differentiate them. So for the first one, I'm going to use the chain rule here. So I've got e to the power of something, and I'm going to use the outside-inside version of the chain rule to do it super quick. So we basically differentiate e to the something, ignoring the something, which becomes e to the something. So e to the 4x squared minus 1, it stays as it is in this case. And then I times by the derivative of the inside. That's the outside-inside rule. So we're going to get 8x. And if I was going to simplify it, I would write it, actually, let me put it here. It'd be 8x e to the 4x squared minus 1. Then g dash x, I'm differentiating 8 ln x. That just becomes 8 over x. So ln x that's the standard result we need to know. You can, by the way, prove that. Why not? Let's do it. So if we had y equals ln x, then that would mean x is equal to e to the y, and I could find dx by dy, which is e to the y, which means dy by dx would be 1 over e to the y, which then becomes 1 over x. So that is a little proof of where it comes from. We're then told that the derivative of f is equal to the derivative of g at x equals alpha. And we're asked to show that alpha satisfies this equation. Okay, so what I can do is write f dash x equals g dash x when 8x e to the 4x squared minus 1 is equal to 8 over x. I feel like I should just make that minus 1 a little bit smaller. I've got to make sure it's clearly in the numerator or in the power. Okay, we somehow want to get an equation involving ln. So what I'm going to do is I'm going to divide through by 8x. I'm going to be taking logs in a second. So e to the 4x squared minus 1 is going to equal 1 over x squared. Or maybe I write it as x to the minus 2. Because now I can undo the exponential and get a log equation, or I could imagine doing ln of both sides. I'm going to get 4x squared minus 1 equals ln of x to the minus 2. And that becomes minus 2 ln x. And then we're there. We're going to get 4x squared plus 2 ln x minus 1 is equal to 0. So alpha will satisfy this. That was part B. Now for C, we're given an iterative formula. By the way, this iterative formula was obtained by making 4x squared the subject here. It would be 1 minus 2 ln x, then dividing by 4, and then square rooting. And this allows you to do something called fixed point iteration. The question's not testing us on that, but we would draw y equals x for the left-hand side, and then the function might end up looking like that. And then we're going to be putting a value of x in, finding what the function gives us, then setting it, basically then set x back to be that value, put it in again, and you can converge towards a solution for when these two are equal. And the solution for when they're equal is the same as the original. Just wanted to remind you about that. In our case, all we need to do is substitute in the 0.6 and then do the iteration lots of times to get alpha. So quickest way to do this is to do 0.6 equals, get it stored in the answer button, and then we'll do the square root of 1 minus 2 times ln, that's shift log, then it's going to be answer that I use. At the moment, that's 0.6, and then I'll be dividing through by 4. And that gives me my x2, my second value. It's going to be 0.7109. 71. Let's just write a few more figures down, 923, and then round it. I think this is always best practice, 0.7109. And then to find alpha, we don't have to do any kind of sign change stuff here. Sometimes you have to show that it's something corrects some amount of significant figures, but it's going to be a little bit simpler here. We're just going to keep pressing exe, which is going to, what this is then doing is putting my new answer back in to get a new value of x. And this is our iterative method. And we've got to do it quite a few times, but that's okay until it seems to be converging. And that's definitely converged to 4 decimal places now. So you can get it as accurate as you want using this method. We're just going around that spiral and we're going to get 0.6706. I might again just write down, I don't know, I just like to write down a few more and then round it. So we've got a 4 in there. Okay, that's all right. Then 0.6706. That is our value of alpha, the root. Well done.